Hey guys, here we are. We are in the home stretch, only a couple of weeks, 3 weeks to go. And of course, we have to be doing one of our toughest sections in this online learning environment. So what I'm going to do is this week I'm going to give you a couple of different videos to show you how to factor. And then we're going to have a required review meeting to make sure you get it, to make sure that you understand before we take a quiz over it. And that will actually be our last quiz. So yay. Okay, so this is factoring is the opposite of simplifying. So let me take you down here. These are where it says warm up. This is what you are used to. And so you're used to doing these type of problems that we have done here. I believe I did that. Okay, so we are used to doing these. This is distributing and, combining like terms if necessary. I'll just do one just to remind you. I don't know why this keeps doing that. But okay, there we go. 3a squared plus 7a. So you multiply the coefficients and add the exponents. This is simplifying. Simplifying means get rid of the parentheses. Distribute, multiply, it's combine like terms. That's what simplify means. It means make it as small as possible, do the operations that are there, and I like to say get rid of parentheses because factoring is the opposite of simplifying. So factoring, they're going to give you a polynomial and you are going to make parentheses. And you're either going to make one set of parentheses, you might make two sets of parentheses. But basically, factoring is splitting it up. What multiplied to get this polynomial? Did you FOIL it? Did you do some other method, which I'm going to show you? And so that's what factoring is. Factoring is what multiplies to get this polynomial. So, and I'll even write that down here. What multiplied to get polynomial? We are making parentheses. So I am going to go down here to these. Well, I'll go ahead and fill in this word here. It says what are polynomials that cannot be factored are called prime. I'll show you one of those, but we won't have very many of those. That's when it can't be factored, and I'll show you what that means in a minute. But let's do GCFs first, because it is the simplest of all the factoring. And you want to look for it in first every time to make it easier to factor. So these first problems that we're going to do just involve GCFs, which are the greatest common factor. And I think you might remember what factors are. So like the factors of 6. So 6, the factors of 6 would be 1 times 6 or 2 times 3. And that's it. So those are the factors of 6. And you're going to see my little t-tables here a bunch when we get further down. When we're talking about the greatest common factor is when you are given two numbers. So I have 27 and 18. And I want to know what is the greatest factor that they have in common. Basically, what is the biggest number that will divide into both of those? Now, if you see these, you might think, 3 goes into both of those. Well, that's true. 3 goes into 27 9 times, and 3 goes into 18 6 times. So 3 is a factor. But if you thought for another minute, you might think of the greater one, which would be 9. So the GCF here for these two, the greatest common factor is 9. All right, so now I'm going to look at this other example here. So if I have 4a squared, and I have 8a, and I have 2a AB. What is the GCF for this group of terms? It's not a polynomial because it doesn't have plus or minus in them, but it's just a list of terms, and I want to know what is the GCF for these three terms. Well, first we're going to see what would divide into all of them. Well, I think that's pretty easy to see that 2 would divide into all of them. And then we're going to look at the letters. Now, what letter do they have in common? Well, they have an A in common. The first one has 2, but they don't all have 2, so they all have at least 1. So I'm going to say that A would be the letter that they have in common. They definitely don't all have B. So this is what we're going to be doing. We're going to be finding the GCF, and then we're also going to see what's left. So this is what I'm talking about. So the procedure that I am going to teach you guys for GCF is put the GCF here and then write what's left in parentheses. Like I said, when we're factoring, we're making parentheses. So this first one, let's see, what goes into 3 and 12? And yes, if it goes into itself, that is a factor. Remember up here, it said 1 times 6 is 6. So this works, and 1 works too. We don't use 1 as often because it's usually not the greatest, but sometimes it is. Sometimes that's all there is. So this one, I think they both divide by 3. So what I'm going to do here is I'm going to divide 3 as the GCF, and I'm going to write that here. The GCF is 3. Then I'm dividing both of them by 3 to see what's left. Well, 1x, and you don't have to write the 1, and 12 divided by 3 is 4. What's left? And that's just to show you. The GCF was 3, so I divided them both by 3, and I found out what was left. Number 2, same thing. GCF, well, it's 7. If it repeats, it's 7. So I'm going to put my thing here. It's 7, so I'm going to divide them both by 7, and that means I'm going to have 1y minus 1. If there is not a letter to hold that, so that you know that the 1 is there, then you need to write a 1. Never leave it blank. That's why one of the reasons I wanted to do this one, because 7 divided by 7 is 1. It's never blank. Okay, if you start with a binomial, you will end up with a binomial in your parentheses. All right, one more of these, number 4. I believe 5 goes into both of these, so far it's been pretty easy. So my GCF is 5. I'm going to divide them both by 5 to see what's left. What's left is 1x plus, and then 30 divided by 5 is 6 with a y on it. That's all they have in common. So far they haven't had any letters in common. Well, let's go ahead to the next section. And here they are going to have a little more in common. And it's not too bad. It doesn't get very much harder than this. I'll just do a few examples and then we'll go to the next section, the next half of this. So we will have some common letters too. So let me show you, like with number 6 here. Number 6, I see that 4 goes into 24. I think I remember that. So let's see, 4 will be my GCF. So I'm going to divide them both by 4. But they also have a letter in common. So I am going to write that letter, just like I did in my first example. They both have a y in common. So see how I'm doing that? Both of them. They have the 4 and the y in common. So now I'm going to divide by 4y. That leaves me with 4 divided by 4 is 1. And then subtracting the exponents leaves me with a single y. That is a y, not a 4. Hopefully you can see that. Then 24 divided by, and it's minus, 24 divided by 4 is 6. And y divided by y is 1. It's gone. It's y to the 0. Remember, you subtract exponents and it's gone. It turns into a 1. So I still have a 6. And there's my final answer there. Let's look at number 9. Number 9. Now, if you saw this right away, you might say, oh, 5 goes into both of those. You're right. 5 goes into both of those. But a bigger number goes into both of those. And If you aren't sure, you need to use your calculator and test it because 15 also goes into both of those. So the number is 15, and they also have letters in common. A, they both have an A, and they both have a B. So they had a lot in common. So now I'm going to divide them both, 15AB and 15AB, to see what's left. And what's left is 1A here. That cancels, and 2 minus 1 is 1A. 30, it's minus. Negative 30 divided by 15 is 2. A's gone, B's gone. Done. Because they cancel. And you can see that they cancel. All right, let's move down a little bit. I'm only going to do a couple more of these because I want to get into the next section. It's a little bit more. This, I think you guys probably have this, but I am going to show you a couple that people get stumped on, like number 11. This happens a lot, and that's why I want to do it. So for number 11, the only thing they have in common is an A. No number this time. It would be 1. So when I divide these both by A, I have a B left on the first part, but I have a negative 1 left on the second part. A divided by A is 1. You can say 1 minus 1 for the exponents is 0, and that turns it into a 1, but you need to write it somehow. Don't leave it blank. There will be a 1. You start with a binomial, you'll have a binomial in the parentheses, just like I said before. All right, looking at 13. So for 13, I don't think they have anything that goes into both of them. They have a 1, but that really doesn't count in this case. So I don't have anything. They don't have any letters in common, and this is where I was talking about with the prime. It's the only one on the entire page. And I just wanted to show you, when you have something like this, you will be told if there is a prime on any evaluations. I am probably not going to give you one because it happens rarely in the problems that you get. But I did want to show it to you. Okay, so 14. I'm going to do 14. Oh, because those are some strange numbers that I'm not sure what goes into everything. So whenever you aren't sure, you can always make a table, which we are going to be doing later. So you might as well look at it now. I have these two numbers. So let's see. I'm going to go ahead and do 1 and 18, 2 times 9, and 3 times 6. Use your calculator. 4 does not go in, 5 does not go in, and then I come back around to 6 so I can stop. 48 has a bunch of numbers that go into it. So we're going to look for the biggest number that matches. We got 1 and 48. Well, we knew that wasn't going to work. 2 and 24, also not going to work. It's bigger than 18. But let's see, 3 times, I think it's 16. So that one's not going to work either. Then we have 4. Let's see, 4 times 12. Well, neither one of those is over an 18. Let's keep going. 5 doesn't work, but 6 times 8. Well, there it is. There's our GCF. So they both had 2 and 3 in common, but we were looking for the greatest. So they both have a 6 in common. So there we go. So we got 6, and I've got A, at least one A, because I can't take out 2 from the other one, so I can only take out as many as they both have. So I can take out an A, I can take out a B, and look, I can take out 2 C's. They have at least 2 C's in common. I can take 2 from each one. So this is my big old GCF. Now when I divide by 6ABC squared and 6ABC squared, and you don't have to do this every time. If you can see it, if you can divide it, you don't have to show me that. So I got 6 into 18 goes 3 times. I'm going to take away one of those A's and keep one. The B's are gone, and both the C's are gone. So I got 3A left there. Minus for the minus. 48 divided by 6 is 8, like I said before. The A's are gone, the B's are gone, and I could take away 2 C's, leaving me with 1. And so there's my final answer there. Okay, last one. I'm going to do number 16 here. So the only difference is I started with a trinomial. That means in my parentheses, I'm going to end up with a trinomial. So what goes into all three of these numbers, 9, 18, and 24, the greatest number? Well, 6 goes into 18 and 24, but it doesn't go into 9. So I'm going to have to stick with what goes into 9. 9 just goes into 18, but it doesn't go into 24. So 3 is going to be my biggest number. So 3, and I'm going to write it over here. And they all have only one R in common. That's all they've got. 9 has a lot of R's, but the other two don't. So 3R, I'm going to divide them all by 3R. And I'm going to get 3R, and this subtract that, you get 7. 18 divided by 3 is 6. And I'm going to have one R left over and an S left over when I subtract those 2 minus 1 on the R's. Then I'm going to have one more subtraction. 3 goes into 24, 8 times, my bad. 8 times, get rid of the R's, left with an S squared. And we stop right there. We want parentheses in the answer. I am now going to continue on to the grouping. So for the grouping, it's basically doing the same thing, and that's why they put it in the same section in the book. It's basically the same thing, but we're just going to be doing it twice. So for this section, we're going to have polynomials with 4 terms. As you can see right here, polynomials with 4 terms. And we are not going to do anything crazy here. We are only going to do 4 terms, and they are all going to work. So let me just go ahead and show you the process. So what you are going to do is you are going to split this up into 2 binomials. And they're going to work the way that this is. We're just going to do the ones that work. We're not going to get crazy. So I am going to split it into 2 groups. I'm going to split it into this group and this group. Now I have 2, because they don't all have something in common right now. So if they had all had something in common, I would have taken that out first. But they don't. They don't all have X. They don't all have a number I can divide by. So I have to group to see if this will work. And now I'm just going to treat it like 2 GCF problems. So the first one, the first group has an X squared in common. I can divide those both by X squared. And when I do, oh, well, it's giving me some room here. So when we do, it's going to leave me with, and so let me go ahead and show you what I'm talking about here. This is what we're doing. That's what you should set up for grouping. I got my GCF, take out 2 X's, leaves me with 1 X plus a 7 because the X squareds cancel out. The second group, they have a number in common. I can divide them both by 2. And that leaves me with, when I divide them both by 2, that leaves me with X plus 7. Now I hope you're going to see that we have matching parentheses. If you don't have matching parentheses, something went wrong, because for the grouping, we're going to have matching parentheses. And that is going to be part of your answer, because like I said, we're making parentheses. And what we are doing is making 2 sets of parentheses. So my final answer is going to be 2 sets of parentheses. The one that matches goes in one. What's left over goes in the other one. And that's it. That's all there is to grouping. So it's basically doing what we just did twice and making 2 parentheses around it from it. Okay, so I am going to do this one, this next one, number 1. I only have a few examples left because this, I'm hoping that this is not that difficult for you. I hope you're seeing it and catching on. So what I'm doing is I am going to group. There's my 2 groups. Then I am going to double GCF here. And I'm going to show you a bit of each type because sometimes there's subtraction. There's a little trickiness involved in a couple of these, but it's basically pretty easy. So this first one, again, just like that first example, X squared. That's all they have in common. Then I can, if I take 2 X's away from that first one, I'm going to be left with 1. So I'm basically dividing these by X squared. And then I will be left with 4 here. This next one, now 4 goes into both of those, but I don't think that's the GCF. 2 goes into them too, not the GCF. 8 goes into both of them. Try it out. Try the 8. 32 divided by 8 in your calculator. Try it out to see if it works, and then work your way down into factors of 8. So yes, 8 does go in here. If you didn't know it, try it in your calculator and figure it out, because we want these parentheses to match, and they will. If you didn't know that, you probably could have divided by 4 and found out, oh, 8 does go. All right, so now I'm going to write my final answer. 2 parentheses. This is my final answer form. Answer. I hit the button. Hold on. Answer form. This is my answer form. 2 sets of parentheses. That's what I want to see for grouping. Okay. And so I put the matching one in 1, and I put the other one. Oh, that's a squared. And I put what's left over. Oh, no, that's right. That was right. It was x squared plus 8. Hold on. My bad. Hold on. Put the matching one in 1. The x plus 4 matched. Don't change it, like I crazy did. And then what's left? X squared plus 8 in the other. Okay. Let's do one more on this page, maybe 2, to show you a couple of different things that will happen. We only have a few examples left. So I'm going to go ahead and bring us down for these 2 examples here. And I am going to do number 4 because something different happens here. So, okay, I'm going to group them up. And it's those negatives that you see. I hope that you see that's what's going to trip us up here. But it's no big deal. We're still going to have our form here. And I put plus every time because we can always make it negative if we take out a negative. I always put plus just to show you that it's there, that it's separated by that. So the first one's easy, k squared again, just like it's been so far. It's just a different letter. So divide both of these by k squared, and that leaves me with a k plus 2. The next one, they have a 5 in common, but they're both negative, so divide out a negative 5. So negative 5. That's what I want you to divide by. Divide them both by negative 5, and that leaves you with k. And negative 10 divided by negative 5 is positive 2. And that's all there is to that. Final answer, 2 parentheses. There's my answer form. I'm going to put the matching parentheses in 1, k plus 2. And what's left over in the blanks, the GCFs, k squared. And you can put minus 5, you can put plus negative 5, whatever makes you happy, because they're the same thing. All right, one more of these on this page. Grouping these and these. Now this is a little different. I don't have just the k squared this time. Let's see how many they do have in common for that first grouping. It looks like they can each have 3 taken out. So I am going to go ahead and put this down. P3. So I am dividing both of those by P3. That leaves me with P2 from the P5. And minus 6 because the P3s cancel. This other one, okay, now this other one has a minus 2 and a plus 12. Now if I just divide those by 2, let's see what happens if I just divide by 2, because that's all that can be divided. So if I divide them both by 2 and I put 2 here, I am going to have a negative 1p squared. But this other one is positive p squared. So take out a negative 2, and let's see what happens if I take out a negative 2. So when that negative is there, you're probably going to take out a negative. So if I divide them both by negative 2, I'm going to have regular p squared, and 12 divided by negative 2 is negative 6. Now they match. I am in good shape. Final answer, 2 sets of parentheses, what matches in 1, and what's left in the other. 2 more examples. And then we'll be done. Number 10. So we're getting into a little bit bigger numbers here, just so you can see them. I'm grouping, and I am going to GCF and see what I take out. So my first GCF, well, 10 doesn't go into both of them, but 5 does, and I think that's all, and then that's right. So 5, but also letters. So 5 and m squared, because I can take 2 out of both of them. When I divide, and if you want to write that on there, divided by 5m squared, divided by 5m squared. If that helps you, go ahead and do it. If you don't need it, you don't have to. So 10 divided by 5 is 2, with 1 m left over. Now I have negative 25 divided by 5 is negative 5, and the m's cancel out. The other side, 4 and 10. Well, 4 and 10, 4 does not go into 10, so what goes into both of those? 2 does. So let's take out a 2 and see what happens. So I'm going to divide out a 2, and I'm going to get 2m, and negative 10 divided by 2 is negative 5. Oh good, they match. They are supposed to, and that's how we're setting them up for you. So my matching one in one of them, and the other set, what's left over, goes in the other one. Last one. Last one. Okay. So I have a GCF for the first one would be 4 and x. Because 8 doesn't go in, but I know 4 goes in. So 4x, and when I divide by 4x, 8 divided by 4 is 2, 1x left over, 12 divided by 4 is 3, and no x left over. Oh, this one has no numbers. Nothing goes into both of those. You are allowed to have 1. You can have a 1. If nothing goes into the second set, you can have a 1. Put your 1 there, you're going to need it. This one also happens to have letters in common, but I wanted you to see that 1. So when I divide out a 1, I get 1, but then I also have the y's in common, so 1y. So what's left is 2x plus 3, and it matches. But sometimes you're going to have just a 1. Keep it. Keep it when you're dividing it out. You got to keep it. If you have a divided by a, don't forget the 1. So I have what matches in one parenthesis, and it doesn't matter if I put the 2x plus 3 in first parenthesis or second parenthesis. It doesn't matter because it's commutative. And then 4x plus 1y in the second one. And that is all I have. I hope that you understood it, and I will be seeing you again in another video later on this week.